Now 2011A2, a biomedical device is shown in the graphic below, generates sound waves at one focus of an ellipse. The waves are then reflected to the other focus to shatter a patient's kidney stones. The drawing on the right shows the directrix, focus, vertex and eccentricity line of an ellipse. Locate the second vertex and the second focus and draw the top half of the curve. So as you can see, from F they've drawn a 45-degree line which hits the line of eccentricity. They've came straight down to locate the vertex. What we are going to do, the exact same thing, only we're going 45 degrees over to the left, dropping it straight down, and there is V1. I'm going to just change that there to V2, and I'll have F1, and to locate F2 we will just keep the distance there between V and F and step it back there. There is F2. Now what I'm actually also going to find here is the very center of the ellipse, and I'm just going to draw my minor axis as well here. So I'm just going to bisect there between V and V1, or V1 and V2. There's my minor axis. Next thing then, like always, I draw my latus rectum. So I put in that there at F1. And now I'm going to put in a series of ordinates. Now first of all, I'm going to bring one up there from between V1 and F1. I'm going to bring one up there between V2 and F2 as well. I'll bring one up from F2, and then I'm just going to space them out there. Okay, keeping relatively even spaces there between both focal points. My next step need to extend my latus rectum up slightly. Is to bring where each of those ordinates intersect the line of eccentricity, bring them across or parallel to the axis. Like so. And then with my compass, put it on F, and I'm going to start here at the bottom where my first horizontal line hits the latus rectum. I'm just swinging it down, and then the others, then I'm just swinging them off over to the right. And there we go. So we have a series of points, and remember where the latus rectum intersects the line of eccentricity, that is a point on the curve. Now you will also notice the line of eccentricity is less than 45 degrees. The reason being, for an ellipse, the eccentricity is always less than 45 degrees. Now what you'll also notice there is that the point on my minor axis, which I found there by bisecting, that is the top of the ellipse. That's the highest point there on the ellipse. And there's then the top half of the curve, which they've asked us to draw in part A. Part B, draw a tangent at a point on the curve which is 70 millimeters from F. So here's my point F. So set your compass to 70 millimeters. and swing off an arc there from F, and I'm going to call that there point P. There are two ways which you can draw a tangent. You will be familiar with one method from junior cert, where you join P to both focal points, you bisect the angle to get your normal, and as you know, your tangent is perpendicular to that normal. The other method, which you will have learned in DCG, will be to join your point to the focus. You would then go perpendicular to the line there, PF, until it hits the directrix, and where it hits the directrix, you would join it back there to P. Sorry, I drew mine a tiny little bit too high there. And then that there will be your tangent.